So once again, this is called a system. There's two equations with two variables. Eventually, we're going to get all sorts of fancy, and we'll have three equations with three variables, so that should be a blast. But we want to make sure we got the basics down. So when everything's kind of lined up nicely like this, we're going to use the method called elimination. To eliminate a variable, we want the coefficients in front to be the same number, but we want the signs to be opposite. So if I want to match coefficients, I'm going to choose the y's. It's just going to be a little bit easier. And I can multiply this by 2 to make that into a 6. And I also want to make that negative to make it opposite. So the main goal is I'm going to multiply everything in that first equation. Oops. The second equation stays the same. And I'm going to add them together. So I want to combine them to make one new equation. That's going to give me negative 4x. That's going to eliminate, which was the whole idea of that step. And that's going to give me negative 4, so x would equal 1. And then from there, we would plug 1 back into either equation. I'll just pick the first original one there. Doesn't really matter which one you choose. And you would just rearrange to solve for y. 3y equals negative 6. So y is going to be negative 2. So my final answer would be the point 1 and negative 2. So just as reminders, hopefully starting to refresh your memory a little bit. If you don't remember that exactly, it's okay. I was just kind of getting a feel for what you guys can remember. Excuse me. So the main goal of today with systems is we're going to do a lot of them graphically. So the nice thing about graphing is you can see what's going on. It's right in front of you. It's a visual thing. But we know graphing can be highly irritating sometimes, so we're not going to do too much of it, especially when we get to some of our more complicated questions. We'll keep it to algebra. But for today, I just wanted to point out a few things with graphs. You have a sheet with a whole bunch of graphs. We're only going to do 2 on the front, 2 on the back. So if you have extra time and you're bored, I don't know, you can do the other ones. I do have an answer key if you ever want to check them. But in general, I'm going to be honest, I kept erasing things and then formatting was getting annoying, so I just kept it how it was. And we can just kind of pick and choose what we need. So what I'm going to do, I'm too lazy to. We are graphing lines. If anyone wanted to use a ruler, I do have them up there. They are all disinfected. I don't think anyone's even touched them for the last week. So if you want to use one, you're more than welcome to. If you want to just kind of freehand it, I feel you. And once again, we're only going to do a few. So let me just get mine up. So mine's a little bit neater. Oh my goodness. All right, so once again, we're just going to pick 2 on the front, 2 on the back. On the front are all systems of equations, so there's equal signs. On the back are all inequalities, so you have greater than or less than. So we just want to make sure we know the difference and what we're looking for and all that fun stuff. So we'll kind of just start with the most basic one with number 1, and then we'll kind of skip around. So number 1 gives us 2 equations. So just as quick reminders, equations, I like to have in slope-intercept form, so mx plus b. The way we graph it is we go to the y-intercept of 2. We're going to do the slope of negative 2 over 1, so we're going to go down 2 to the right 1. What I highly suggest is kind of keep extending your points. So keep going down 2 to the right 1. It just makes it easier to find your answer. You can also go up 2 to the left 1. But with that, we have our nice line. Lines are infinite, so we put arrows on the end. We're just looking at that little part of it. And we basically just repeat that step. Go to your second equation, plot the y-intercept of negative 1. Just be careful with this slope, it's negative 1/2. Just make sure that negative goes with either the numerator or the denominator. I usually just put it with the numerator. Please do not put a negative with both, because then it would make it positive. So from here, I'm going to go down 1 to the right 2. You can also go up 1 to the left 2 if you want to kind of extend it. And I'm going to connect those. Our main goal for actually doing this is to figure out where these lines intersect. So technically we just found that using the elimination, but now we can visualize what's happening. We have two lines, they're meeting at a point, so we find the points they meet at, and we label that as our answer. So the answer to this would be 2, -2. So that's the main idea. We have two lines, what are we looking for? Where they intersect. Just as a heads up, I'm just gonna try to remind you of little things today, things you probably haven't seen in a while. If you have two lines that are parallel, we have a line like this and a line like this. Parallel lines are never going to meet, and if our main goal is to find where they intersect, that's obviously not gonna happen. Your answer to this would be no solution. If you ever get two lines that are the same, so you kind of graph a line, and then you go to the second line, and you're like, hey, wait a second, it's the same exact line. That's basically like putting two lines on top, or putting one line on top of another one. The answer to this would be infinitely many solutions. Great. So I just wanted to point those special cases out. They just randomly pop up, but they do happen. So it's good to know what they look like visually. Any questions with one? All right, let me just skip around here. I'm gonna go to 6. No, I'm not gonna go to 6. I'll go to 4. There's just something I want to point out to you on this one. So number 4, we're looking at it and we're saying, okay, I have to graph that. It's definitely not in slope-intercept form, so we're gonna have to do a little bit of moving stuff around, which is fine. You can do that, no problem. And then we'll talk about the second equation in a second as well. So what I noticed for the first equation is I want to get this y isolated by itself. So that means I don't want that -1/4 in front. You can always cancel a fraction by multiplying by its reciprocal. So the reciprocal of 1/4 is 4. We want to also get rid of the negative, so we're going to multiply by -4. What that does is it cancels the negative and it cancels the 4. You're just left with 1y. But what I do to one side, I have to do to the other side. So I'm just technically just going to write this as y equals -4 times 1 is -4. That's my constant, so I'm just going to put it kind of, that's my b. And then -4 times -1/6, 4/6 would be 2/3, right? So that would be just 2/3 x. But the negatives would cancel each other, so it would turn positive. So we kind of move stuff around. We got the isolated the y. I always like to put it in that mx plus b because that's kind of the standard to graph. So I'm going to go to -4 for my y-intercept. I'm going to rise 2, run 3. I can't really extend that anymore. There's nowhere else to go, so I'll just connect those. Okay, so that wasn't too terrible. So once again, if it's not in the form you need, rearrange it. Get rid of fractions, little things like that. So now I look at the second equation. If I'm trying for slope-intercept form, that's not going to work. There's no y. So these are the little things I want to remind you of back from your algebra 1 days. When you talked about linear equations back in the day, you had horizontal lines and vertical lines. And they just had like quick little equations. A horizontal line has the equation y equals, and that's just equal to a number. And then vertical lines are x equals a number. So what we notice is since there's no y here, I'm just going to isolate that x. I'll subtract the 3. And I'll divide just by a negative to get x equals 3. So that's going to be a vertical line. So if you're ever graphing a vertical line, on the x-axis, you just go to 3, and then you draw a vertical line. You can also think of different points where the x is 3. You change the y, you can get a vertical line as well. Those vertical, horizontal kind of pop up a lot, so I'm just trying to kind of point out things that you might see as we're graphing in the future. But our main goal is what is the answer, and that's right here. you would label the point 3, -2 as your final answer. Excuse me. So I'll leave that up for a second. Other than that, the other ones are pretty similar. You would just go through and always rearrange if things weren't in slope-intercept form. That vertical horizontal lines might pop up, so just as a heads up. And your main goal is always where do the lines intersect, so you're figuring out that point. And then if it's parallel, you would write no solution, and if they were the same, it would be infinitely more. So does anyone have a question on the front? Just the two that we went through. Commutes. So on the back, we're just gonna pick two random ones again. I'm gonna start with 8, I think. Doesn't really matter, but no reason I went from the front. Just trying to get the general idea. On the back, we're talking about inequalities. So we can see now there's no more equal signs. There's either greater than or less than symbols. So we just want to make sure we're okay with graphing those and what our answer is going to look like. Okay. So if I'm doing 8, so once again, I'm just kind of skipping to random ones here. So the first thing I would do if I was graphing an inequality is the same thing I would do with an equation. I would get it into that slope-intercept form. So if I were starting with this first inequality, I would isolate the y. So I'm going to move the x first. I like it in that form of mx plus b, so you might want to move things around. Okay, so that's not going to be too bad to graph. We're going to go to our y-intercept of 5. Our slope is -1. So I'm going to go down 1 to the right 1. For this, you don't really need to. You can put more points if you want to, but you don't really have to. And then just as a reminder, if you remember this, if not, just as a heads up, if you have a greater than or less than symbol with no or equal to underneath, you're going to have a dotted line. If you have the or equal to, it's solid. It's kind of the same idea of open circle, closed circle. We need a way to tell, like, are the things on that line, are they actually equal to it, or are they just approaching it? So in this case, since there's no or equal to underneath, we're going to do a dotted line. And then one more step, you also have to shade. So our inequality says y is less than that line. So what I'm going to do is go to my line, and I'm going to shade everything less than it, so below it. So I'm just going to do kind of a quick, it doesn't have to be anything too fancy. I still have a whole other line to do, so make sure you can still, like, don't get aggressive if we're filling in. Make sure you can still see your graph. But I'll do the second part in a second. I just don't want to rush anyone. Okay, so now we go to the second inequality and we say, all right, I want to put that in slope-intercept form. We'll subtract 2x. Just be careful, it's -y is greater than -2x plus 1. I'm going to have to divide by -1 to cancel that. And back, this is just like the day of little reminders. Back in the day when you were dividing by a negative, you have to flip your inequality. So these are all like little things are adding up, you know, solid, dotted, whether it's horizontal, vertical, no solution, all that fun stuff. And that's just another little thing. When you multiply or divide by a negative, when you're solving an inequality, you have to flip your inequality, just as a reminder. We are going to go to our y-intercept of -1. We are going to rise 2, run 1. Before you connect, you think, is it solid or dotted? This one would be dotted because there's no or equal to underneath. Kind of think about your lines as like a roof, because we have the word slope, so it looks a little different. This says y is less than our line. So think about this specific line. Don't think about right or left. Think about above or below. When I say less than, we're going to be below that line. Think about this line. We're below it. Our answer is not like the front where we have like a nice beautiful point and we were done. Our answer is an entire region of the graph where the shading is meeting. So you want to make sure that if someone, aka like me, if I look at your graph, I know where your answer is, and the shading is meeting in that section. So I always kind of say go back and kind of make it obvious where it meets. So if someone were just to just glance at your paper, they would know where your answer was. So once again, you're not going to have like a beautiful point or one specific answer. Your answer is an entire region of the graph. Any questions with number 8? All right, let's do one more inequality, just so we have a good look at both. We are going to choose one where there's an absolute value. Which one did I want? I don't really care. I'm going to do number 11. Like, I'm just picking random ones. Just trying to switch them up because I did other ones that didn't have. Oh, I have hiccups. So our main goal now is, okay, we're still doing inequalities, so we're going to have a little bit of shading. We do see an absolute value, so we just want to remind ourselves of what the heck that looks like and how do we get that shape. But most of the other stuff is pretty similar. Excuse me. So I start with my first inequality. My y-intercept is 3. My slope is just 1. Okay, so that wasn't too bad. As I'm connecting, I remind myself it would be a dotted line. Pretty terrible line, but you got the idea. And we read the inequality. This says y is less than the line. So think about your line, and less than would be below it. So don't think about right or left, think of above or below. It kind of depends on your slope. Okay, so that was kind of set up nicely, so nothing too crazy with the setup. When you see an absolute value, just a reminder, it is going to be a V shape. So we need to make sure we get that shape. The first thing we want to find from this is the vertex. And the vertex is kind of the point of our V. It all has to do with translations, which we talked about last chapter. So this is telling me my absolute value is being moved to the right one. And since there's nothing down here, it's not being moved up or down. So the vertex would be at 1, 0. So I go to 1, 0. Whatever the coefficient of this absolute value is, there's technically a 1 out there. That's your slope. So what I do from here is just kind of do your slope of 1, and that's fine and dandy. But remember, it's a V shape, and the V is symmetric. So you just kind of go in the opposite direction as well. You go -1. Okay. You don't have to do a million points, just a few to kind of get that idea. We're going to connect them. We're going to use a dotted line. This says y is greater than my absolute value. Hopefully it makes sense when you think about your v. Greater than is going to be above the v. So I'll just kind of do it in this direction. Extending my things. Mine got a little messy there. So that's why it's always good to go back and just remind yourself, where is the shading meeting? It's just meeting in this little section, right? So if you glance at my graph, you would be able to tell that that's where the answer of that was. And that's kind of the main idea going into this chapter. We're going to be talking about systems. We can now visually imagine what the answers are meaning, but we know graphing is kind of a pain unless we have our computers or our graphing calculators with us all the time. We're going to do a lot of it algebraically, so we'll do more of that stuff tomorrow. We did our warm-up with it today. I will warn you, some of the answers aren't very nice tomorrow, so just like bring your calculator tomorrow. Okay? It's gonna be, without a calculator, it will be a big pain in the butt. With a calculator, it's not as bad, because you're just plugging in. Just be prepared for some ugly answers. That's okay. So what I want to do, I wanted to have time to do this because I'm always the worst. I always keep papers forever and I don't want them. And I know you guys like to see what you got, and I don't blame you. I'm going to call you up, so if you could just come grab your paper when you hear your name. And I want to actually look at these because as we're moving on, yeah, we're done with that chapter, but everything we do this year has to do with functions. So if you have questions, I would like to clear them up. So we will do that. So what happened is that graded problem set was out of 60. So it did technically count as an assessment, but your actual test counts with more points, so it counts for more out of the final. No matter what, no one grade was hit too hard by either. You guys all have, I believe, everyone pretty much has an A in here, so you guys are doing good to start.